12,900 years ago, something happened. The air temperature dropped 15 degrees Celsius in less than a human lifetime. The warming world that had been lifting itself out of the last ice age, over 2,000 years, the glaciers retreating, the forests creeping north, the megafauna spreading onto newly opened plains, that world reversed. The ice sheet stopped melting. The seas paused. The winter came back. It stayed for 1,200 years. The climate scientists who first read this story out of Greenland ice cores in the late 20th century had to check their numbers 3 times. What the ice was telling them did not match what they had been taught climate could do. Climate was supposed to change slowly. Climate was supposed to take centuries to move a few degrees. The ice was telling them something else. The ice was saying that in a single human lifetime, the world had plunged back into a cold nobody had been expecting, and that it had done it in a heartbeat. They called the interval the Younger Dryas, after a small white wildflower, whose pollen reappeared in European lake sediments during the cold, displacing the warmer vegetation that had been spreading the century before. When it finally lifted, around 11,700 years ago, the world that walked out of the long winter was no longer the world that had walked in. The great mammoths of North America were gone. The saber-toothed cats were gone. The giant ground sloths, the dire wolves, the short-faced bears, the glyptodons, all the slow-moving giants of the Pleistocene were gone. The Clovis hunters who had built their whole way of life around those animals had vanished from the record. Their descendants scattered into smaller, quieter cultures that would leave fewer marks, and in a small corner of the Fertile Crescent, in what is now southern Turkey and northern Syria, a handful of frightened foragers had begun to do something their grandmothers would have found unthinkable. They had begun to plant. The Younger Dryas is the reason you live the way you live. Every city on earth, every temple, every market, every written word, every religion anyone has ever heard of, all of them grow out of what happened on the other side of that long cold. They grow out of people who were forced by 1,200 years of winter to invent a new relationship with the earth. And the question of what actually caused the Younger Dryas, whether a comet broke apart over North America and flash froze half a hemisphere, as some scientists still argue, or whether a lake of glacial meltwater flooded the Atlantic and shut down the currents, as most now believe, that question has become one of the quieter wars in modern science. This is the story of that winter, the evidence, the arguments, the claims that have been made, and the claims that have not held. Because the channel has always been about the crossroads where deep time meets human history. This is the story of what our world would look like if the cold had never come, if the ice had just kept melting, if the warming had just continued, if the mammoths had kept their plains, and the Natufians had kept their wild grains, and the bend that twists every human story of the last 12,000 years into its present shape had never been bent at all. What would that world look like? And what does the fact that we will never see it tell us about the fragility of our own? To understand what the cold broke, you need to understand what the warm was building. The world of 14,700 years ago had been, by any reasonable standard, a planet on the mend. For tens of thousands of years before that, during the worst of the last glacial maximum, ice had ruled the northern hemisphere. Sheets of it, miles thick, covered Canada and the northern United States. Another sheet blanketed Scandinavia and Britain. Sea levels were 120 meters lower than today. The Sahara was a dust bowl. The Amazon was smaller. And human populations across Eurasia had contracted into a handful of refugia where the climate remained tolerable. Around 14,700 years ago, almost without warning, the Earth warmed. Climate scientists call this warm interval the Bølling-Allerud interstadial, after the Danish sites where its signature was first recognized. For roughly 2,000 years, from 14,700 to 12,900 years. Before the present, summer temperatures in the northern hemisphere climbed rapidly back toward modern values. The ice sheets, still dominant, began to crumble at their edges. The forests of oak and pine began their long march north. The rivers swelled with meltwater. The seas began their long climb back toward modern levels. Human populations did what human populations always do when conditions improve. They moved into land that had been empty for millennia. They followed the herds that were pushing north behind the retreating ice. Across North America, the people we now call the Clovis, named for the New Mexico site where their distinctive spear points were first recognized, spread from Alaska to Tierra del Fuego in a demographic wave that may have taken no more than a few centuries. They were hunters of giants. Their spear points, fluted, beautifully napped, designed to penetrate thick hide, were found wedged between the ribs of mammoths, jammed into the spines of mastodons, scattered around the butchering sites of long-tusked elephants, whose kind had walked the Americas for millions of years. The Clovis lived in a paradise of meat. The late Pleistocene Americas held an animal community that has no modern analog. Woolly mammoths and Columbian mammoths, mastodons of several species, giant ground sloths, some the size of modern elephants, short-faced bears, which at 11 feet standing were the largest terrestrial predators the continent has ever held, saber-toothed cats, American lions, armored mammals the size of small cars, four-horned antelope, American cheetahs, camels, native to the Americas, which would go extinct and return only thousands of years later with the Spanish. The Clovis hunted or lived beside. Across the Atlantic, another slow transformation was underway. In the hills of the Fertile Crescent, the region that curves from the eastern Mediterranean up through southern Turkey and down into Mesopotamia, human populations were taking a first tentative step towards something their species had never quite done. They were staying put. These were the Natufians, and for the last 2,000 years, before the Younger Dryas, they had been inventing sedentism. Not fully, not completely, but in ways that are visible in the archaeology. At sites like Ain Malaha, in what is now Israel, and Jericho in the Jordan Valley, Natufian communities were building small, round houses, half sunk into the ground, with stone foundations and wooden roofs. They were burying their dead beneath the floors, much as Çatalhöyük would later do. They were harvesting wild cereals with sickles made of flint microliths set into bone hafts. They were processing grain in stone mortars. They were making jewelry of shell and bone, sometimes traded from 100 miles away. They were not yet farmers. They did not plant. They did not sow. What they did was gather and store the wild grasses of the fertile hills, wild einkorn wheat, and they did it so well in a landscape so rich that they could afford to live in the same spot for generations. They had found a way to stop walking. Across the whole northern hemisphere, at the same moment, the world changed again. The warming that had lasted 2,000 years stopped. The cold came back. The detail that still astonishes the people who study this event is the speed. The Younger Dryas, as far as we can reconstruct from ice cores, did not arrive gradually. It did not creep in over centuries. It did not dim the summers and then dim them more until people noticed the glaciers had stopped retreating. It did none of that. It arrived in a human lifetime. In some regions, possibly in a few years. The Greenland ice cores, the GISP2 and GRIP records, which drilled down through hundreds of thousands of years of annual snow layers and hold them in physical storage for scientists to read layer by layer, show the onset of the Younger Dryas as an almost vertical line. The isotope ratios of oxygen trapped in the ice, which are a proxy for air temperature at the time the snow fell, drop abruptly. Within 20 to 50 years, atmospheric temperatures over Greenland fell by roughly 15 degrees Celsius. 15 degrees. For comparison, the temperature difference between a comfortable spring day in London and the deepest freeze of a Montreal winter is about the same. The Younger Dryas delivered that transition as a global forcing in half a century. The record is less extreme, but still shocking. Lake sediments in Germany and France show rapid cooling of 5 to 7 degrees Celsius on a similar timescale. Glaciers that had been retreating for 1,000 years surged forward. Again, the oak and hazel forests of the early warming died back. The taiga and the tundra returned. Across the continent, reindeer herds that had drifted north pushed south again, their range expanding into the cold valleys of Central Europe. Where the Natufians had been thriving, the signal is different. The temperature drop there was smaller, but the precipitation collapsed. What had been a relatively wet, well-vegetated landscape turned dry. The wild grain harvests that had been so reliable became unpredictable. Oak forests thinned. The gazelle herds that the Natufians had depended on shrank, and the Natufian settlements, which had been growing for 2,000 years, began to contract. The late Natufian period shows smaller villages, more ephemeral sites, a shift back toward mobility. In North America, the mammoths started to die. This is one of the great archaeological puzzles. The megafauna extinction in North America is a real event. By around 12,800 years ago, the great giants are vanishing from the record at a rate that no previous interglacial has seen. The causes are debated. Human hunting pressure from the Clovis and their descendants almost certainly played a role. Climate stress from the sudden onset of the Younger Dryas almost certainly played a role. A hyperdisease hypothesis has been proposed and largely rejected. The old dream that a single cause can explain the whole extinction has given way to a more honest recognition that it was a compound disaster. But the timing is striking. The bulk of the North American megafaunal extinctions cluster in a narrow window from roughly 12,800 to 12,600 years ago. That is the opening centuries of the Younger Dryas. The cold did not finish them off alone, but the cold caught them at the worst possible moment. Population fragmented, already under hunting pressure, and it broke them. The Clovis broke with them. The distinctive fluted points of the Clovis tradition disappear from the archaeological record at almost exactly the same time as the mammoths they were designed to kill. The human populations did not vanish. Genetic studies confirm that the descendants of the Clovis are still with us, folded into the ancestry of later Native American cultures. But their way of life ended. They could no longer be hunters of giants because the giants were gone. 1,200 years. That is how long this winter lasted. Generations of children grew up and died during it, never knowing the world before. The babies born in the first decade of the Younger Dryas would have been 90 years old before the cold eased a single degree. Their great-grandchildren would be the first humans in 1,000 years to see a full warming sky. Around 11,700 years ago, just as suddenly as it had come, the Younger Dryas ended. The ice cores show the temperature rise almost as abruptly as they show the fall. The forests came back. The rains returned to the Levant. The world lifted itself back into warming. It would not turn back. We have been in the warm interval ever since. It is called the Holocene. The Holocene is the world you live in. But between the warming before and the warming after sits 1,000 years of cold that nobody has yet fully explained. Now we have to talk about the comet. In 2007, a team of 26 scientists led by Richard Firestone published a paper in the Proceedings of the National Academy of Sciences that proposed something dramatic. The team argued that the sudden onset of the Younger Dryas was caused by the impact or the low-altitude airburst of a comet or cometary fragment over the North American ice sheet. Their hypothesis, which came to be known as the Younger Dryas Impact Hypothesis, often abbreviated YDIH, rested on several pieces of evidence. At dozens of sites across North America, and at a smaller number of sites in Europe and the Middle East, the team reported finding a thin, dark, stratigraphic layer, dated to right around 12,900 years before the present. Where they found it, it sat directly above the last Clovis artifacts and directly below the first post-Clovis cultures. Where they found mammoth bones, those bones were below the layer. Above the layer, the mammoths were gone. They called it the black mat. Inside the black mat, they claimed to have found a suite of unusual materials, tiny crystalline diamonds that could only have formed under the extreme pressures of an extraterrestrial impact. Magnetic microspherules and carbon spherules, both of which are sometimes produced in impact events. Concentrations of iridium and platinum, elements that are rare in the Earth's crust, but common in many meteorites. Traces of vaporized and recondensed minerals that resemble those found at known impact sites. In broad strokes was this: a comet had broken up over the Laurentide ice sheet, the great continental glacier, covering much of North America. The airbursts from its fragments had not left a conventional crater, because the ice absorbed the impacts, and because airbursts at altitude may not produce craters, but they had showered the landscape with debris. The heat had triggered massive wildfires, whose soot contributed to the dark layer. The shock had disrupted the ice sheet and potentially flooded fresh water into the North Atlantic, and that disruption had initiated the cold. The comet, in other words, had ended the Ice Age, because of its own effects had sent the world back into one. It was a compelling story. It had everything: a cosmic cause, a precise date, a dramatic mechanism, a tidy explanation for the megafaunal extinctions, the Clovis disappearance, and the climate shift all at once. Outside of science, the hypothesis caught fire. Authors like Graham Hancock, who had long argued for a lost advanced civilization destroyed by cataclysm, embraced the impact hypothesis as evidence for their view. Podcasts amplified it. Documentaries dramatized it. social media filled with comet impact animations and confident assertions that the science was settled. For a certain kind of audience, the YDIH became, over the following 15 years, less a scientific claim and more a cultural certainty. Inside of science, things went differently. From the first year of the hypothesis, skeptical specialists began to examine the claims piece by piece. And over the following decade and a half, by 2025, the pieces had mostly not held up. Start with the nanodiamonds, because they were the strongest claim. Crystalline carbon structures on the scale of billionths of a meter do form in impact events. High pressure, high temperature, the right chemistry, a meteorite impact, or a large airburst can produce them. If you find them in a specific thin stratum, that stratum has a story to tell. The trouble is confirming that what you have found are actually nanodiamonds. A team led by Tyrone Dalton at Washington University in St. Louis took a fresh look at the samples that had been used to support the original Firestone paper. Using higher resolution transmission electron microscopy and more careful identification criteria, they concluded that the particles being identified as nanodiamonds were, in most cases, something else. They were aggregates of graphene and graphane oxide, flat carbon structures unrelated to impact. Some had been misidentified as the rare hexagonal form of diamond, which had been one of the stronger pieces of the original claim. Dalton and his colleagues found no Lonsdaleite. Later analyses replicated this result. In 2016, another review by Dalton and colleagues across a wider range of samples confirmed the pattern. The nanodiamond signature, as originally claimed, did not consistently appear in independent examinations. This was not a small problem for the hypothesis. If the nanodiamonds were not really there, one of the strongest pillars of the evidence had collapsed. Now the crater question. Every known major impact event on Earth has eventually been tied to a crater. The Chicxulub impact that ended the Cretaceous left a crater in the Yucatan, 66 million years old, now traceable in great detail under the shallow sea. The Tunguska event, a much smaller airburst over Siberia in 1908, left no crater. But that was an object perhaps 60 meters across, producing effects felt over a few thousand square kilometers, not a continental-scale catastrophe. A Younger Dryas impact of the scale required to trigger a continental climate collapse should have left something. If not a classical impact crater, then at least a buried melt structure, a magnetic anomaly, a shatter zone visible in deep geophysics. For years, the YDIH had no such structure. Then, in 2018, a team working with ice-penetrating radar in northwest Greenland announced a remarkable find. Beneath the Hiawatha Glacier, they had imaged a circular depression 31 kilometers across, with the structural features of a large impact crater. They suggested it might be young. They suggested it might even be Younger Dryas in age. The community held its breath. Further dating work, using argon-argon techniques on grains from the impact site, was published in 2022. The result was definitive. The Hiawatha crater was indeed an impact structure, but it was approximately 58 million years old. Late Paleocene. Not Younger Dryas. Not close. The crater that had seemed, briefly, to vindicate the hypothesis was from a completely different era. The platinum anomaly, meanwhile, had been showing up in ice cores and soil samples around the Younger Dryas boundary. This part of the evidence is real. there is a detectable spike in platinum concentration in Greenland, ice dated to around 12,800 years ago. But what the spike means is contested. Platinum enrichment alone is not a unique signature of impact. Volcanic activity, changes in atmospheric dust transport, and even some industrial contamination scenarios can produce similar anomalies. One of the leading impact cratering experts of the past half-century calculated that an object large enough to produce the claimed platinum spike as impact debris would be of a size we should expect to encounter only once every few million years, statistically unlikely to have arrived precisely at the end of the Pleistocene. And the black mat, the dark layer at the center of the hypothesis, turned out to have at least one mundane explanation. In many of the sites where it appears, it corresponds to a wet, swampy environment that followed the onset of the Younger Dryas climate shift. Waterlogged soils, decaying vegetation, and high organic content produce dark strata routinely. The layer is real. What it means is a matter of interpretation, and the interpretation that does not require a comet is, by most measures, simpler. A comprehensive review, published in 2023 by archaeologist Vance Holliday and others, looking across all the evidence that had accumulated over 16 years of the debate, concluded that the Younger Dryas impact hypothesis had failed to converge on a consistent, reproducible, and predictive explanation. In 2025, the Skeptical Inquirer ran a long-form piece by planetary scientist Mark Boslow, simply titled "The Younger Dryas Impact, a Failed Hypothesis." This is where the mainstream science now sits. Not that the hypothesis has been disproven with finality. In science, almost nothing is. But that the weight of evidence has moved against it. The strongest claims have not held under replication, and most of the specialists who work on the Pleistocene-Holocene transition have moved on to other explanations. The people who still defend the YDIH are not a fringe of non-scientists. They include working researchers, some of whom publish in peer-reviewed journals, some of whom argue, not without reason, that the rejection of their hypothesis has been premature and tinged with the sociology of a scientific community that dislikes drama. But they are, at this moment in 2026, in the minority of their field, and the minority has been shrinking. So if not a comet, what? The leading alternative, and the one most climate scientists working today consider the best supported explanation for the Younger Dryas, is not a rock from space. A vast, slow, catastrophic flood of water. Its name is Lake Agassiz. At the peak of the last ice age, the Laurentide ice sheet, the continental glacier covering most of Canada and the northern United States, held, locked up in its ice, a sizable fraction of the planet's fresh water. As the ice began to melt during the Bowling-Allerreid warming, that water had to go somewhere. Much of it flowed south, carving the great meltwater channels that still mark the modern continental interior. Much of it pooled at the edges of the retreating ice, trapped between the wall of the glacier and the land, forming enormous lakes that had no modern equivalent. Lake Agassiz was the greatest of these. At its maximum extent, it covered a territory larger than the combined modern Great Lakes, stretching across what is now Manitoba, Saskatchewan, Ontario, Minnesota, and the Dakotas. Its waters were held back in part by the ice itself. As the ice retreated, different outlets opened and closed, channeling the lake's drainage in different directions at different times. The working hypothesis is this. Around 12,900 years ago, some combination of further ice retreat and catastrophic dam failure opened a new outlet for Lake Agassiz, probably an eastern route through what is now the St. Lawrence Seaway, or possibly a northern route through the Mackenzie Valley and into the Arctic Ocean. The geological evidence for a sudden discharge of a massive quantity of fresh water into the North Atlantic around this time is extensive and by most standards robust. A pulse of fresh water into the North Atlantic matters enormously because the North Atlantic is where one of the planet's major climate regulating systems does its work. It is called the Atlantic Meridional Overturning Circulation, or the AMOC. The AMOC is a great loop of ocean water. Salty surface water from the tropics flows north on the Gulf Stream, reaching the high latitudes of the North Atlantic, where, cooled by the Arctic air, it becomes dense and sinks. The sunken cold water then flows south, deep beneath the surface, beginning a global conveyor that circulates water around the whole planet, before eventually returning to the surface thousands of years later. The AMOC is the reason Western Europe is not a subarctic wasteland. London, at 51 degrees north, is on the same latitude as Calgary, but London's winters are mild because the Gulf Stream is delivering the heat of the tropics to its coast. Disrupt the AMOC, and the North Atlantic margin cools dramatically. Shut it down entirely, and Northern Europe and Northeastern North America plunge into something that looks a great deal like a Younger Dryas. Here is the mechanism. The circulation depends on the density of the sinking water, and density depends on salinity. Dump a massive pulse of fresh water into the North Atlantic, and you lower the salinity of the surface layer. The water stops sinking. The engine stalls. The heat stops flowing north. The northern hemisphere cools. This is not a speculative mechanism. Climate models, run forward and backward, reproduce Younger Dryas conditions when a meltwater pulse of the appropriate size is added to the North Atlantic at the appropriate time. The physics works. The geological evidence for the pulse is present. The timing fits. It is, by a wide margin, the best supported hypothesis we have. It is not the only one. A handful of researchers argue for volcanism. A handful argue for solar variability. A handful argue that the Younger Dryas was less global and more regional than the Greenland ice cores. Make it look. The literature is genuinely open in some respects. But if you had to bet in the year of this recording on what triggered the Younger Dryas, you would bet on the meltwater pulse and the AMOC shutdown. You would not bet on the comet. And here is the honest, important thing about the difference between these hypotheses. For the question we are about to ask, what would have happened if the Younger Dryas had not occurred at all? The cause does not actually matter. It does not matter whether you blame a comet or a flood or something we have not yet identified. What matters is whether the cold came. So let us now, with the cold on the table, ask what might have happened without it. Let us pull a single thread from the fabric of the last 12,000 years and see what unravels. Imagine that at 12,900 years ago, nothing breaks. The warming that had been underway for 2,000 years simply continues. No comet drops any of its fragments over the Laurentide ice sheet. No catastrophic breach empties Lake Agassiz into the North Atlantic in a single millennium-long event. The AMOC stays strong. The Gulf Stream keeps pumping. The forests keep pushing north. The ice sheets keep crumbling. The winter of 1200 years never arrives. The Earth simply slides out of the Ice Age over the course of another 1,000 or 2,000 years into the warm interval we now call the Holocene. Now we run the tape forward and we watch. At first, the differences are small. The Clovis hunters of North America continue to spread. Their population grows. Their spear points refine. For a few centuries, the record would look much like it actually does. A successful culture, expanding into rich country, following the herds, adapting techniques to new regions. But here is where the first divergence begins to appear. In our actual timeline, the megafauna of North America collapsed during and just after the Younger Dryas. In the counterfactual timeline we are now exploring, the climate stress that helped finish them off never arrives. The mammoths do not face a sudden 15-degree drop in Greenland and the corresponding regional effects in the Americas. The grasslands they depend on do not contract. The browsing patterns of the mastodons, adapted to a particular mosaic of forest and meadow, are not disrupted. The short-faced bear, at the top of a complex food chain, continues to find its prey. Without the climate catastrophe, would the megafauna have survived? This is not a trivial question. Even in our actual history, climate was not the only factor. Human hunting pressure from the Clovis and their descendants was almost certainly significant. Some researchers argue that humans alone would have eventually driven the megafauna to extinction, even without any climate event. Others argue that the megafauna had survived dozens of previous glacial cycles, each with their own climate swings, and that the unique addition of skilled human hunters was the decisive new variable. The truth is almost certainly somewhere in the middle. Human predation and climate stress compounded each other. Remove the climate stress, and the extinction is probably not avoided entirely, but it is slower, more uneven, and potentially incomplete. In our counterfactual, the Columbian mammoth might hold on in isolated refugia for another 1,000 or 2,000 years. The American horse, which remember was native to the Americas and went extinct there before being reintroduced by the Spanish, might persist as a wild species, perhaps eventually to be domesticated by later indigenous cultures. The ground sloth, a slower breeding and more vulnerable species, probably still goes. The short-faced bear, with its complex prey requirements, is harder to call. What you would see in this counterfactual Americas of, say, 8,000 years ago is a richer, stranger ecosystem than the one that actually exists. Not the full Pleistocene cast of characters, some of them were already on their way out, but a retained fraction. Mammoths in the Midwest, horses on the plains, sloths in the forests of the Southeast, American cheetahs on the grasslands of what is now Texas and Colorado. This is a continent that would look, to a time-traveling modern visitor, a little bit like East Africa still looks today. Vast grasslands with megafauna still on them, complex predator guilds, the full trophic machinery of a system that never had its top layer pulled out. And the human cultures that lived alongside those animals would be different too. The Clovis way of life, built around the hunting of giants, would not have had to reinvent itself. The cultural transition from Clovis to Folsom to the scattered regional traditions of the mid-Holocene would have looked different, or possibly would not have happened at all. The Clovis might have simply continued, slowly diversifying for another several thousand years. The first wave of human impact on the Americas happened anyway, but the second wave, the long adaptation to a megafauna-free continent that defined so much of pre-contact Native American civilization, might never have been necessary. The Americas, in the counterfactual, are richer and more ancient than the Americas you know. Now cross the Atlantic and follow what the cold would have never done to the Natufians. In our actual history, the Younger Dryas broke the Natufian experiment. The 2,000 years of sedentary foraging that the Natufians had built in the fertile hills of the Levant was, by 12,900 years ago, a remarkable achievement. They had not yet domesticated a single plant or animal, but they had learned, through careful management of wild resources, how to live in one place, how to harvest the wild grain in its season, how to store it through the winter, how to tell which hillside would have a good gazelle year, how to extract from a landscape that was not yet a farm enough to feed a village. The cold hit them like a hammer. The temperature drop itself was moderate in the Levant, perhaps 3 or 4 degrees, but the precipitation collapse was severe. The wild grain harvests, which had been plentiful, became unpredictable. Oak forests thinned, springs dried. The gazelle herds that had been so reliable shrank. The villages that had been growing for generations began to break apart. The late Natufian archaeological record is one of contraction. Smaller sites, more mobile populations, a retreat from the painted stone houses of the early Natufian back toward the temporary camps of a more nomadic life. Somewhere in the late Younger Dryas, or just at its ending, in the hills around what is now Syria and Turkey, some of these struggling foragers began to do something new. They began to plant. This is the origin of agriculture in the Fertile Crescent, and it is almost certainly not an accident that it happened when it did. The leading hypothesis, shared by archaeologists, paleoclimatologists, and evolutionary theorists across multiple disciplines, is that the cold and dry centuries of the Younger Dryas created a desperate need for predictable food, and that the response across a scatter of late Natufian communities was to stop waiting for the wild grain to come and instead to put it where you wanted it to grow. The first experiments were probably small, a handful of barley seeds cast into a favored patch of earth near a reliable spring. The memory, a year later, that the grain in that patch came up thicker than the wild grain further out. A second year, a third year, a widening of the patch. The invention, gradually, of the sickle specifically for harvesting a cultivated field. The invention of the threshing floor. The invention of the grain bin. Within a few centuries of the end of the Younger Dryas, the Fertile Crescent had become the birthplace of agriculture. Wheat, barley, lentils, peas, chickpeas, flax, 8 foundational crops, each domesticated from a wild ancestor, each still fundamental to human nutrition 10,000 years later. Now pull the cold back out. In the counterfactual where the Younger Dryas never happens, the Natufians continue their slow expansion. The wild grains remain abundant. The gazelle herds remain reliable. The villages grow larger. The seasonal mobility that had been reduced but not eliminated in the early Natufian is perhaps further reduced. The houses become more permanent. The burial practices become more elaborate. The social complexity probably grows. But the pressure to invent agriculture is not there. Why would you plant a seed if the wild grain is already thick in the hills? Why would you invent the threshing floor if the wild harvest is enough? Why would you take the enormous risk of binding a human community to a specific field for a specific growing season when the whole point of being a Natufian was that you had found a way to live well without that risk? The honest answer is that you might not. Not immediately. Not at all in the same time frame. Agriculture might still have been invented eventually, perhaps several thousand years later, when population pressures or other climate fluctuations eventually created a similar squeeze. But the rapid flowering of the Fertile Crescent Neolithic, the explosion of cultivated crops, domesticated animals, and sedentary villages that defined the 10,000 years from 11,500 years ago to the present is a specific historical event shaped by specific pressures at a specific moment. Remove the Younger Dryas, and that moment is a different moment, or it never arrives. Which brings us almost unavoidably to the question of Göbekli Tepe, the astonishing stone ring complex in southeastern Turkey, radiocarbon dated to somewhere between 11,600 and 8,200 years ago, is in the actual timeline one of the first great monumental expressions of the post-Younger Dryas world. Its builders lived in the first few centuries after the cold ended. They were hunter-gatherers and very early agriculturalists in the transitional generations between the late Natufian way of life and the fully Neolithic one. What they built is still unlike anything else from that period. Circles of carved limestone pillars, some standing 5 meters tall, arranged in concentric patterns. Animals carved in high relief: snakes, scorpions, vultures, foxes, wild boar, lions. Abstract symbols whose meaning we cannot yet read. Burial features inside the enclosures. Layers of deliberate infilling, where one generation would bury an older ring under tons of gravel before starting a new one. A site used for 3,500 years by people who, on every measure we use to define civilization, should not have been capable of organizing labor on this scale. The leading interpretations of Göbekli Tepe all share a common feature. They see the site as, in some deep way, a response to the trauma and transformation of the preceding millennia. A cosmology built by people who had just come through the coldest centuries their ancestors could remember. A monument to survival. An attempt to tell the new story of the world after the ice. The archaeologist who led the first decades of excavation at the site before his death in 2014 put it in a striking way. He argued that Göbekli Tepe was not simply a precursor to agriculture. It was one of the drivers of agriculture, the labor required to build and maintain the site, to feed the workers, to provide for the ceremonies, to support the specialist stonemasons, exceeded what a purely foraging economy could sustain. To build Göbekli Tepe, people had to invent surplus, and to invent surplus, they had to invent the systematic cultivation of grain. The temple came first in this reading, and the farm followed. Now remove the Younger Dryas. In the counterfactual, the Natufian communities of the Fertile Crescent continue their trajectory of slow, comfortable sedentism. There is no trauma of collapse. There is no desperate reinvention. There is no compressed transitional period of people who had been stable for 2,000 years and were now, for climate reasons, forced to reimagine their entire relationship with the landscape. Would the builders of Göbekli Tepe have built Göbekli Tepe? Almost certainly not. At least not on the same timeline, and not with the same character. Göbekli Tepe is a product of a particular psychological moment. It is what a population does when it has just come through the hardest winter in memory and needs to make sense of it. The art on its pillars, the vultures tearing at headless human bodies, the snakes coiling beneath the lions, the sudden proliferation of death imagery, is not the art of a comfortable culture. It is the art of a culture that has seen a lot of death and is asking, on scales nobody had ever asked before, what it was all for. In the counterfactual world, that psychological moment never arrives. There is no reason to build it. And without Göbekli Tepe, the cascade of subsequent developments in Neolithic Anatolia, the early sedentary sites, the emergence of Çatalhöyük, the whole foundational network of the first settled communities in the Fertile Crescent, takes a different shape. Maybe they still happen later, under different pressures. Maybe they take radically different forms. Maybe, in some versions of this counterfactual, agriculture is invented instead in South China, or in the highlands of Papua New Guinea, or in the Andes, each of which were already doing their own experiments with plant cultivation independently. Maybe the center of the world, civilizationally, shifts. Or maybe, and this is the harder possibility, the whole Neolithic revolution is delayed by 1,000 or 2,000 or 3,000 years. Because a revolution, in the end, is a response to a pressure. And remove the pressure and the revolution waits. Now follow the thread further. The Neolithic revolution, the invention of agriculture, and the long, slow transformation of human society that followed, is sometimes called the most consequential event in human history. It is the hinge on which everything else turns. Cities, writing, metalworking, organized religion, empires, law codes, industry, science, the internet, the room you're sitting in, all of it grows by unbroken cultural descent out of the villages of the early Neolithic. Remove the Neolithic on the timeline it actually happened, and you remove almost all of it. In our counterfactual, where the Younger Dryas never arrived and the Natufians were never squeezed, agriculture is delayed, perhaps by a few centuries, perhaps by a millennium, perhaps by 3 or 4 or 5. This does not mean that agriculture never happens. Human populations continue to grow. Climate continues to fluctuate. The Holocene is not a perfectly steady, warm interval, even in reality. Sooner or later, somewhere, some population will face a pressure sufficient to drive the cultivation experiment. Perhaps in the Yellow River Valley, where rice and millet would have been domesticated independently. Perhaps in Mesoamerica, with maize. Perhaps in the highlands of Papua New Guinea, where taro and banana cultivation began independently only a few thousand years later than Fertile Crescent agriculture in the actual timeline. The Fertile Crescent may simply lose its primacy. In the counterfactual, the first great centers of settled civilization might rise in East Asia, or in Mexico, or in the Andes, thousands of years earlier than they did in fact, relative to the Near East. The entire balance of world history might tilt eastward or southward, or the rise of civilization might simply happen later, across the board. If the first wave of fully Neolithic villages arrives in 8,500 years before the present, instead of 10,500, that is 2,000 years of delayed development. The pyramids of Egypt in this scenario would be built around 600 years before the Common Era instead of 2600. The birth of writing in Sumer around 3,000 years before The Common Era in actual history might be a late medieval event in the alternate timeline. The Industrial Revolution might be happening now, in the late 26th century, instead of 250 years ago. All of this is speculative. Counterfactual history is a genre of careful guessing, not prediction. But the directional logic is sound. Remove the trigger, delay the response. Delay the response, delay the cascade, and the cascade is everything. Because it is not just agriculture that delays, it is everything that depends on agriculture, which is everything. Metalworking requires surplus. Somebody who is not hunting or gathering must have the time and food to experiment with rocks and fires. Metalworking is thousands of years after the first farms. Writing requires the bookkeeping needs of agricultural societies. Nobody invents writing in a forager band. Writing is thousands of years after the first farms. Monumental architecture, the pyramids, the ziggurats, cathedrals, requires populations of tens of thousands. Surplus food, organized labor, centralized religion, and the settled conviction that a place is a place. All of these are downstream of the Neolithic. The city requires agriculture to feed it. The state requires the city to administer. The empire requires the state to expand. The Industrial Revolution requires centuries of pre-industrial urban development. The internet requires, in a chain of about 300 steps, every single prior technological milestone. Pull the thread at 12,900 years ago, and all of these events lose their anchor. They may still happen, but they happen later. They happen differently. They happen in different places. They happen, in some cases, in forms we cannot imagine, because our imagination is so thoroughly shaped by the actual historical path that we struggle to see around it. The smooth warming, the preserved megafauna, the comfortable Natufians, the delayed Neolithic, the later cities, the later states, the later everything. This is what a world without the Younger Dryas might look like. It is not necessarily a better world. It is not necessarily a worse one. It is, most importantly, not the world that produced you. So what does the alternate present look like? I want to be honest about the limits of what can be said here. Counterfactual history compounds uncertainty at every step. Each decision node branches. Each branch has its own logic. By the time you have run the tape forward for 12,000 years through a world whose single largest climate event has been removed, you are no longer doing history. You are doing science fiction. But the channel has always insisted on trying, carefully, to imagine. So let me try. In the alternate world, the year we call 2026 might not exist as a date at all. The Gregorian calendar, the Christian era, the entire chronological framework, all of that would require a different sequence of specific events to come into being. You cannot have the Common Era without a specific empire having dated itself from a specific event. But let us pretend that in this alternate world, some civilization does maintain a calendar of approximately the same span, and let us imagine their equivalent of our current year. What would they see looking out at their world? They would see almost certainly a less populous planet. If agriculture arrived 1,000 or 2,000 years later, and the subsequent development was delayed in proportion, the total population at our equivalent date would be markedly smaller. Our 8 billion might, in the alternate, be 3 or 4 billion. They would see an Americas whose human cultures had never experienced the shock of arrival by Europeans. Not because the ships never came, but because the ships never had the technological or demographic pressure to sail. Maritime empires that emerged in the European medieval period came from a specific trajectory of post-Roman state development, itself dependent on 1,000 previous steps. In the alternate, Europe might still be predominantly agricultural, in what we would call its early Bronze Age. They would see, potentially, the full Pleistocene megafauna still walking, partly in thinned forms. Refugial mammoths in northern Canada, horses on the American plains, ground sloths in refugia of the southeast, a continent whose wildlife, to modern eyes, would look shockingly ancient. They would see, and this is the strangest part, a relationship to deep time that we have lost. Every culture that has existed since the Neolithic has lived downstream of a dramatic break. The Younger Dryas, then the invention of agriculture, then the rise of cities, then the long march of recorded history. Our cultures are characterized by this sense of forward motion, of discontinuous progress, of the distant past as something fundamentally different from the present. In the counterfactual, the break may simply have been gentler. The forager cultures of the post-glacial world might have persisted for longer, in more places, in more complex forms. The transition to agriculture, when it finally came, might have been less traumatic because it was not compressed by climate emergency. The relationship to the land, to the animals, to the seasons, might be one of slow accretion rather than of sudden reinvention. It might be, in many ways, a world more like Tzatelhoyuk writ large, deeply continuous with the Paleolithic, technologically modest by our standards, but perhaps, in its way, more comfortable in its relationship to time. And here is the thing that should stop you for a moment and make you look at your own hands. The person in that world would also be you. Not you in the sense of the same individual. The chain of specific ancestors that produced your specific body requires millions of specific events that would not have happened in the counterfactual. But you as a human being, your cognitive capacity, your emotional architecture, your hopes, your fears, your talent for love and for betrayal, your deep craving for patterns and stories, all of that is Pleistocene equipment. It was fully modern by the time the Younger Dryas hit. It would be fully present in the person sitting by a different kind of fire, in a different kind of house in the alternate year of 2026. The machinery of being human is older than the Neolithic, which means that the real difference between our world and the counterfactual is not in us. It is in what we have built. Our cities, our technologies, our histories, our specific gods and specific languages. These are the layered consequences of a cold snap 12,000 years ago. They are what we built. They are not who we are. Who we are, we have been, since long before the cold. And now, we have to come back. Because this has been, after all, a thought experiment. The alternate world does not exist. The comet, if there was one, probably was not. The meltwater pulse almost certainly was. The cold came. The Natufians planted. Göbekli Tepe rose. Agriculture spread. The cities were built. You are sitting in the world that actually happened, not in any of the ones that could have. So what do we take back with us? Renewed respect for how thin the chain is. The civilization you inhabit is not the inevitable outcome of human potential unfolding. It is a specific sequence of responses to a specific series of pressures, starting with a climate event we still do not fully understand. 12,900 years ago. If that event had not occurred, or had occurred differently, The whole scaffolding on which you have built every assumption about the shape of human life would be different. This is not a comfortable thought. It is not meant to be. It is meant to locate you accurately in the actual size of the universe you live in. You are small. Your civilization is young. The chain that brought you here is not made of steel, a real feeling for what the ancestors walked through. The people of the Younger Dryas did not know they were in a transition. They did not know the cold would end. They did not know that the strange experiments some of them were making with wild grain would eventually feed 10 billion of their descendants. They did what every generation of humans before them had done. They lived, they struggled, they loved each other, they buried their dead, they kept going, and in keeping going, they invented, without intending to, almost everything we now call civilization. The Natufian mother who laid her daughter in the earth beneath her house. The Clovis hunter who put down his spear for the last time because there was nothing left to hunt. The first person who deliberately planted a seed of barley in a specific spot and came back a year later to see what had grown. None of them thought they were making a new world. All of them did. Third, a different relationship to catastrophe. When you read about climate change today and hear predictions of what might happen to human societies if temperatures rise by another 2 or 3 degrees, remember the Younger Dryas. Remember 15 degrees in a human lifetime. Remember 1,200 years of cold. Remember that the last time the Earth's climate lurched in a comparable way, our species did not collapse, but we did not come out of it unchanged. We came out with our entire relationship to the Earth rewritten. The climate machine can do things you have not yet seen it do. It has done them before. It will, in some form, do them again. The question is not whether humans can survive such an event. The Natufians survived. Their descendants are still here. The question is what kind of civilization stands on the other side? One last question. Why does the Younger Dryas impact hypothesis, despite everything we have said about its scientific standing, refuse to die? The answer has nothing to do with the evidence, and everything to do with the kind of story human beings like to tell. A comet is a better story than a meltwater pulse. A single dramatic event with a clear cause and a clear moment is more satisfying than a complex chain of glaciological and atmospheric interactions that probably unfolded over decades. A cosmic visitor from the dark speaks to something ancient in the human mind, the same part of the mind that once saw gods in the night sky, that still stops when a meteor crosses the horizon, that wants to believe the universe is paying attention to us. The meltwater hypothesis, by contrast, is honest and boring. A lake drained into an ocean. The ocean's engine stalled. The north got cold. The hypothesis explains the evidence, makes testable predictions, survives replication, and does not require anything unusual to have happened. It is the kind of answer that wins in science, and the kind of answer that loses in culture. Graham Hancock and his intellectual descendants have spent 40 years building an industry on top of the cataclysm story. A lost advanced civilization, a cometary doom, a knowledge hidden from the mainstream. Millions of readers, millions of viewers, a whole worldview that depends on the catastrophe being real. To release the YDIH in their framework is to release the whole edifice. But the catastrophe you need does not require the comet. The Younger Dryas was itself a catastrophe. regardless of its cause. A 15-degree drop in Greenland in a human lifetime is a catastrophe by any definition. The collapse of megafauna was a catastrophe. The end of the Clovis was a catastrophe. The trauma that pushed the Natufians to invent a new way of living was a catastrophe. The universe does not need a comet to be dramatic. The universe managed to be dramatic all on its own, through the quiet interaction of a melting lake and a cooling current. And the honest story is, at the end, stranger and deeper than the dramatic one. It is stranger that the world was transformed by fresh water, sinking at the wrong rate. It is stranger that the foundation of modern civilization rests on a slow collision between glacial meltwater and ocean salt. It is stranger that we are who we are because of a specific current pattern in the North Atlantic 12,000 years ago. Nothing in the honest story is less remarkable than the commentary one. It is just remarkable in a different way. It asks you to find awe in the ordinary machinery of the planet, rather than in a visitor from the dark. Some people, clearly, will always prefer the visitor. But if you have walked with us this far, and if the honest machinery has been worth it, you know now that you do not need the comet. The machine is enough. The machine is almost too much. 12,900 years ago, something happened. A lake, perhaps, broke through its icy dam and emptied a continent of cold, fresh water into the salt dark of the North Atlantic. A current, perhaps, slowed and stalled and stopped. A sky over Greenland, perhaps, lost its heat in the span of a single human generation. Something did. We know the result. The result was 1,200 years of winter. The result was the end of the mammoth and the saber-tooth and the Clovis spear, and the long tradition of hunting giants that had walked with our species across 2 continents. The result was a quiet, terrified people in a small corner of the Fertile Crescent, standing over a patch of wild grain and asking themselves what would happen if they put some of it into the ground. The result was you. Not because any of those people meant to produce you. Not because the cold meant to produce anything at all. Because in the long chain of contingent events that stretches from a high glacial lake to a living body reading this page, one link was the Younger Dryas, and without it, the chain would not reach this far. You are standing at the end of that chain. You did not ask to be. You will, like every generation before you, add a single small link of your own. Some of what you add will last. Most of it will not. And 12,000 years from now, if any descendants of your kind are still asking the questions you are asking, they will stand at the end of a chain that includes you. And they will wonder, just as you're wondering now, at the arbitrary, extraordinary fact that anything is here at all. The cold ended. The warming returned. The Holocene, the long warm summer of our species, began. And in it, for better and for worse, we became what we are. The bend in the line 12,900 years ago was not a triumph. It was not a disaster. It was not a prophecy. It was weather. A weather on a scale so large that no individual human alive at the time could have understood what was happening. And we, on the far side of it, have built everything on top of what it left behind. Remember the Natufian mother. Remember the Clovis hunter with his last spear. Remember the first person to plant a seed. They did not know what they were beginning. You do not know what you are ending. And the long, strange, contingent story continues. Somewhere, tonight, in a different branch of time, the cold did not come. The mammoths are still walking. The Natufians are still gathering. The world is quieter and older and slower. You are not in that world. You are in this one. For all of its noise and its speed and its trouble, this one is the one we have and the only one we ever will. Every civilization before us was a response to what came before. Every civilization after us will be a response to what we have done. The line is not a plan. The line is a story. And the story goes on. Thank you for walking through the cold with me. The echoes, as always, continue.